Now we need to focus our energy on doing even better next time. That's what our goal is. Now, some of you have still not made the correlation between daily homework and study and success. If you're really, really smart, I mean just an awesome math student, just really smart, then you don't need to worry about daily homework and study. But if you're not, then you need to do daily homework and study. You can't say, oh gosh, Miss Ford's not going to collect this for another week, so I'm just not going to do it. No, you have to do it every day. You have to keep that brain functioning. Okay, so back to this problem. Now, what did we decide was the issue here? This is number, the one we stopped with, number 27. And our job was the same as it was here. Find the vertex and axis. That one I can look at. I don't have to do any work. There's the answer. Vertex, right 1 and up 5. I need to make this equation look like that. Now you did this last year. And I'm going to warn you right up front, there are going to be fractions involved. Suck it up. Okay? Like my favorite t-shirt, which, I don't know, we may get next year. On the front it says, or I don't know, maybe it's all on the front, I don't know, it says, math is hard, so is life, deal with it. This is hard, only because of the arithmetic. So, here's what we're going to do. We're going to complete the square. So I'm going to move that 4 over to the other side. And then I'm going to divide the whole shebang by 3. All right, so step 1. Whatever that is, get it over here. If there's a coefficient, divide it out. We're getting ready to complete the square, and to complete the square, this has to be a plain x squared. Now, I know you would rather not divide by 3 because of all these fractions, but you don't get to choose that. You have to divide by 3. Now, I'm going to add something to both sides. You should remember how to figure out what to add. How do I figure out what I'm going to add to both sides? I take half of that. So when it's a fraction, I like to multiply it by a half instead of divide by 2. Same thing. What's half of 5/3? 5/6. And then what do I do with that number? Square it. So I'm going to add 25/36 to both sides. We are completing the square because we want to have this kind of equation, right? So we need a square. So we took half of this and squared it. Half of 5/3 and squared it. And that's what we added to both sides. Now, these two have to be added together. So we're going to have a 1/3 y plus. Now, how am I going to add these two things together? And 3 and 36, that would be 36. So I have 48 and 25, which is 73/36. Got a common denominator here, so it's 48 and 25. Now this should be my square. That should look like this. So what square is that? X plus, what? Not 5/3, 5/6. Remember, when you square it, you got to get that number, so it would be 5/6. So now you've got your squared quantity, which was your goal. The only thing we have to do now is get y back by itself again. So let's move this guy back over. So we're going to subtract the 73/36. And then there's one more thing left to do. What do I need to do?
Get rid of the one.
Times by 3. Now, be careful. When you times by 3, it means everything, but not inside the parentheses.
So you just put on that.
So it's just on the outside of the parentheses. So you're going to have y equals 3x plus 5, 6 squared minus, okay, now this is 7336 times 3 over 1. So what's going to happen here?
You can cancel.
And we're going to have 73 twelfths. Don't get bogged down with the arithmetic. You know how to add and multiply and stuff. Now remember, the question was, where's the vertex? So where is the vertex of this parabola? How has this one been moved? Left 5, 6, and
Up,
down 73 twelfths. So your vertex left 5, 6, down 73 twelfths. Now think about that for a minute. Here it is. This would be your axis of symmetry. This is the point -5, 6, -73 twelfths. What would be the equation of this line right here, your axis? X equals -5, 6.
So that would be your AOS.
Your axis of symmetry, yep. All right? Pain in the butt. In a minute, we're going to talk about a shortcut. But there are times when we need to be able to do it this way. So we're going to go ahead and do one more. I'll just pick another one out of the book. How about 32? It has a negative in it. All right, so let's see if we can get through this. It's going to have fractions in it too. All right, how do we start? Do you remember? Well, we're going to complete the square, but we can't just jump in and do that first. First, we have to do some stuff. What do we need to do? Add the 4. We need to get rid of that 4. And then what else do we have to do? Divide everything by -2. So I have -1/2 y minus 2 equals x squared plus 7/2 x. Everybody okay with that? Dividing everything by a -2? And you do that so that this is a 1. Now we're going to complete the square. So how do we do that again? We look at this number and take half of it. So what is half of 7/2? 7/4. And then what do we do with our 7/4? Square it. So to both sides, I am going to add
7/16.
49/16.
Yeah, that's what I meant.
Now you need to add these together. They're like terms, so they need to be added. You're going to add -2 over 1 and 49 over 16. You're going to add these two together. So what do we need to do to add them? Get a common denominator.
Could you cancel? Cross.
No, not when I'm adding. Only when I'm multiplying. Not when I'm adding. So I have a -32 and a positive 49. That's going to be positive 17.
Yes.
So I have -1/2 y plus 17/16 equal to, all right, now this should be a perfect square. X plus, not 7/2, 7/4. Remember, when you square it, you got to get 49/16.
All right, so then you subtract 17.
You got to get y by itself, so we'll move the 17/16 over to the other side.
And then times 8 too.
-2. We're going to multiply by -2. But remember, not inside the parentheses. Do not multiply inside the parentheses. But you are going to multiply this by -2 over 1, which is going to give us a positive. Oops. Positive what?
34/6.
Well, 34/16, but that'll reduce to 17/8. So where's your vertex? Left 7/4 and up 17/8. So -7/4, comma 17/8. That's my vertex. Left, up. This one opens down. Why? Because it's got a negative. We'll find it by negative. That flips it over the x-axis. Here's your axis of symmetry. What would be the equation of that line? X equals -7/4. Now, there are going to be many problems. I got the hiccups again, doggone it. There are going to be many problems where all you care about is the vertex. Because in a parabola, the vertex is either the maximum or the minimum, right? And so when we do problems like the box problem, where we're looking for a maximum, I know, I don't know what, ever since I've had cancer, I get the hiccups like 18 times a day. It doesn't have anything to do with it, I'm sure, but I just do. So, if my problem involves finding the maximum or minimum, and it's a quadratic, then all I care about is the vertex. I don't need this number, I don't need any of that stuff. If you're finding the focus and the directrix, are these words familiar to you? If you're finding all that stuff from analytical geometry, then you need this form. All right, so I'm going to give you another option, but I'm going to tell you the other option only works if your goal is simply to find the max or the min. Okay, here's the other option. We'll just do this problem. You're going to love it because it's way easier. It just doesn't give you the whole picture. There is a formula for the axis of symmetry. And it's real easy. X equals -b over 2a. Do you remember that?
Yes.
This is the formula for the axis of symmetry. So, if I look at my equation, here's A, here's B, here's C, just like the quadratic formula. So x would equal 7 over 2 times -2, or -7/4. Now, is that what we got for our axis of symmetry when we did it the long way? Yeah, and that sure is a lot faster, isn't it? Now, that is the formula for the axis of symmetry. How can I get my vertex, which is a point? Your vertex is a point. How can you get that from this? We know that the x-coordinate is going to be the axis of symmetry, right?
So plug it in for x.
And so you plug it in for x. Now, so you're still going to have to do some fraction work. So you put that right back in here. So we have -2 times, all right, what's this squared?
-49.
49/6.
No, it'd be positive. You're squaring it, so it's going to be positive. Minus 7 times -7/4 minus 4. Okay, so here we go. That's -49/8, because I'm multiplying by 2 over 1, plus 49/4 minus 4. Now, what do we need to do there? the common denominator, which would be 8. So I have negative 49 plus 98 minus 32. Okay. Is that 17? Was that the vertex we got when we did it before? Sure was. Alright, so now you have another method of finding the vertex. Negative b over 2a, which gives you your x value, your axis of symmetry. Okay? Alright. Now, the next set of problems, starting with 39 and 40 and all that, says write the equation of the parabola. So I'm going to do 39, you're going to help me. We have a vertex at the point -1, -3, and the parabola contains the point 1, 5. So again, we're switching gears. We've already figured all this stuff out. Now we're on to this problem set number 39, where they draw a picture of it for you, but now you got to come up with the equation. You got to come up with the equation of the parabola. Now, I want you to think about the easy form, what we call the vertex form. This is an example of the vertex form of a parabola, right? You can look at this and tell me the vertex is at -1, -4, because you went left 1 and down 4, right? Now, if they tell me the vertex, can I at least fill in part of this equation?
Yeah.
So what would that look like? In the parentheses would be what? X plus what? 1.
Squared.
And then on the end would be -3. Would everybody agree that that much at least I can do?
Yes.
Okay. Now here's what I want you to think about. The vertex of this was -1, -4. Where's the vertex of that one? -1, -4. Where's the vertex of that one? There are a zillion, billion, trillion parabolas that have a vertex of -1, -4. It all depends on how fat or skinny or what direction it opens, right? So it depends on this missing number here in the front. I have no idea which parabola I'm talking about, but I know it has to go through that point. So think about it. I know this equation has to fit that point. Any idea how I might find that in? Plug the point in. Sure. You've been given an x and a y, right? A specific x and y. So if I put 5 in here and 1 in here, can I figure out what the right end is? There's only one end that's going to make the parabola go through that point. So what is that end? Well, let's see. 1 plus 1 is 2, and 2 squared is? I'm going to go buy a lottery ticket. This is too cool. Look at this, how nice this is going to work out. So now, n equals 2? Oh, wait a minute. I didn't make this problem up, did I?
No.
Oh, yeah, no. Yeah, they This is number 39. So what's the answer to the question? Y equals 2 times x plus 1 squared minus 3? Let's go ahead and do 42, just for extra practice. I'm doing a bunch of your homework for you.
Oh, thank you.
I know. Vertex -1, 5, and axis of symmetry 2 negative, or no, not axis of symmetry, contains the point 2 negative 13.
What number is this?
This is number 42.
42.
Okay, so here we go. Step 1. We know the structure of the equation, right? Isn't that the structure of the equation? So what can we fill in right from the get-go? Parentheses will be x plus 1, and here on the end will be plus 5. Because this parabola has gone 1 left and up 5. The only thing I don't know is how big it is. But I do know it has to hold that point. That point has to be on this curve. So what do I do with that point? Plug it in. So this is your x, this is your y. So negative 13, 2, so negative 13 equals, all right, 2 plus 1 squared, 9n. They've rigged another one for you, so n works out nicely to be. So this number right here is negative 2, and there's your answer. Does that picture open down, I hope? Yep. Okay. Now you got some regressions. I want you to look at some word problems now. Let's pick a good one here. Let's try 56. We're going to try problem 56. All right, so everybody in section 2.1, number 56. All right, as soon as we get it done, I'll be quiet, okay? So hang with me, Charlie. Number 56. We have a large painting that's 3 feet longer than it is wide. So here's the painting, and it's 3 feet longer than it is wide. So tell me what to do with that. W and 3 feet longer. W plus 3?
Yeah.
Is that okay? Now, this is 56. The wooden frame is 12 inches wide. Okay, so this thing has a, move this inside. So we've got a wooden frame around it. And it is 1 foot wide. The area of the picture and frame is 208. Okay, so the area of the whole thing is 208. Now, to find the area of a rectangle, we do length times width, right? So tell me what the width of this whole thing is. Now, I know the picture was W, but remember we put a frame on it. So what's the width of the whole thing? W plus 2. Pardon me? Because you're adding 1 plus W plus 1. You're not doubling it, you're adding to it. Now what about the length of the picture here? What would that be? W plus 5. And according to the problem, if I multiply the length times the width of the whole thing, it equals 208.
So, all equals 208?
So now I'm going to FOIL it.
Is that 88?
208 out of the problem. Do you have your book open?
I do.
Okay, well then you know where the 208 came from. So W squared plus 7W minus what? 198 equals 0. Is that okay? Now, what's the question? I got my equation all set up. Find the dimensions of the painting. We need to solve that equation. We don't need the vertex. Some of the problems you'll need the vertex, not this one. You want to solve that equation. So what do you want to do? So if you're a really good factorer,
Can you do that?
is this 18 times 11?
Yeah.
So if you're a really good factorer, you can go ahead and double check that, is that right?
Yep.
So W equals negative 18, I don't think so. That's extraneous. Or W equals 11? So the dimensions of the painting, is that the question? Yeah, the dimensions of the painting are 11 by 14. And there are more in this section, different kinds of problems, sort of like 1.7 was, just a bunch of random type problems. You should now be able to do 2.1. So the 2.1 assignment, you should be able to do. It's pretty long because there's a lot of problems in there, but you should be able to do that.
You were